Hello everyone. So in this talk, I will introduce the techniques we developed in this project. So the purpose is to ensure data and devices on the farm are protected and trusted. So I will introduce two techniques. The first one is a new blockchain platform. So basically, this platform can be applied to every stage of the this supply chain diagram. The second is a lightweight encryption algorithm. For this, it's applied the on-farm node, you can see on this diagram. So as we have seen in the previous talk, so IoT devices are attached to cattle or sheep. So these devices are collected much behavioral data about the animals. So this data is supposed to be shared with the other stakeholders in the supply chain. So then they may be used for different purposes, like provenance tracking, animal welfare protection, or any other purpose like compliance check. Yeah, it's open. So for the stakeholders in the supply chain, they may have some questions about the data. For example, they may ask, has the data been tampered with after collection? Or who generates the data with the water rules or underwater conditions? Particularly, some stakeholders might be in different countries. So in this project, we need to solve the trust problem raised from the stakeholders. So for the trust problem, blockchain is a useful tool. Blockchain is a decentralized ledger. So the data on the blockchain is immutable, and the blockchain is tamper resistant. Because of it's decentralized, then it can be trusted by stakeholders from different countries. So the benefits of applying blockchain in supply chain is well known, but it's only conceptually well known. So the blockchain can improve the transparency or visibility of the supply chain, or it can enable end-to-end product tracking. So in this project, we have a new blockchain. Its name is called EnerID blockchain. So its novel feature is that it significantly lowers the barrier of using blockchain. And we hope it can promote the concrete application or adoption of blockchain in supply chain and make the benefits real. So our blockchain, the EnerID, it means the energized identity. So we think it's the most accessible public blockchain in terms that anyone can record data into EnerID blockchain just with ordinary computing devices like your smartphone or just like your laptop at any time. More importantly, without cost. So I think maybe all of us are familiar with the free internet services. Just like the Gmail, it's a free email service, or YouTube, it provides the free video service. For EnerID blockchain, it has the potential to become the first free public blockchain service service providing platform. So this table, in this table, we compare the EnerID blockchain with the existing blockchain techniques. Suppose we are in a scenario, a farmer just would like to record the data into the blockchain for convincing his farm is compliant with some policies, or convincing the consumers his farm is organic. So as we have seen in the previous talk, there is a lot of paper form the farmers need to complete. So suppose the farmer just wants to put the data into the blockchain. So the current blockchain, there is a public ones and the private ones. So suppose the public ones is used first, like the Bitcoin blockchain. So if the farmer would like to use the Bitcoin blockchain, he needs to have Bitcoin. It's not cheap. It's very expensive recently again. And if the farmer would like to mine the coin, Bitcoin by himself, then he needs to invest on powerful specific machines. That's also not easy. It needs first thing, it needs cost. Also, it needs skills to maintain such machines. For other public blockchains like the Ethereum blockchain, the farmer still needs the chain sticks, the coins on the particular blockchain. So there is also other private blockchain. For example, there's a food blockchain or beef blockchain. For these private blockchains, so the farmer needs to pay some membership fees. Sometimes it's also not cheap. Some private platform needs the farmers to pay like above $100 per month for the usage. And another problem is that for the private blockchain, the farmers and their customers needed to trust the company that maintain this platform. So this is not very consistent with the decentralization feature of public blockchain. For EnerID, our blockchain is public. So a farmer just like using the free email service or free Google service, so just put their data into the blockchain. Moreover, when using this blockchain, the farmers can earn some coins. So these coins might link farmers to other economic activities. So if we want to adopt blockchain in supply chain with the current blockchain techniques, usually there is a dilemma. So as I have talked before, so it's the current blockchain is not free for farmer. So if there is no obvious return value, it's also the value problem is also discussed in the panel discussion. Why people would like to join the blockchain-based platform? So on the other hand, if there is not so many people or parties to join, then the feature of blockchain cannot be fully used. For suppose only one farmer is using the blockchain, then the data can't be tracked. The transparency and visibility does not make too much sense. So for EnerID blockchain, we can address this dilemma. So stakeholders in the blockchain can implement their business functionalities without any cost burden caused by the blockchain technology itself. So from this point of view, so suppose more and more business functionalities are built over the EnerID, then EnerID can enable an ecosystem for the supply chain stakeholders. So the ecosystem component, for example, it can be business identity management, data management, finance management, policy declaration. It can be determined by the stakeholders themselves. So with this ecosystem for the supply chain, we believe the value of blockchain can be bootstrapped. That means the value of blockchain can be manifested step by step. We don't expect on one day the blockchain supported supply chain adopted by all stakeholders. It must be adopted step by step. So here I give a little bit more details of some example business activities for this ecosystem. So the first functionality is the identity and trust relationship management. So with the current EnerID blockchain, suppose we have the different stakeholders like government, companies, farmers, or retailers. They can, first step, they can simply put their identity onto the blockchain. And then they can build trust relationship among themselves. For example, so government agencies in one country can certify the working relationship with the government agencies in another country. So the government agency, for example, in Australia, can certify the farmers in particular area. For example, this farmer is a real Australia farmer or farm. And the Australia transportation companies can also be certified by a government agency. And the farmers also can certify their products are being transported by some company or sold to some company, or their farmers are being monitored by devices manufactured by some companies. Basically, the relationship is also open. They can record any relationship. So another,
just giving you a 1 minute warning.
Okay. Yeah. Okay. Thank you, Sky. So another component is the data and the business process management on the chain. Basically, farming activity, order management, consumer commands, any data, transport date or condition can be recorded. So with the data and the identity over the chain, so for example, there are some regulators from the government or from some company can make the management policy. For example, what animal welfare rules are considered, what conditions for defining organic farm or carbon friendly farming condition. Then based on the data and the identity, so the agency can certify this farm is compliant with animal welfare rule, is a real climate change friendship farm, or any certificate they can issue. From this, so the maybe finance management can be involved too. For example, if the farmer is doing very well protecting the environment. I saw some news in BBC about the experiment in UK about, so if the farm is doing very well for climate change protection, then the tokens can be issued. So that can be used for payment, also for stimulus package payment. And also the divestment can be managed over this chain too. So this is the architecture of EnerID. Basically, there is the user and the server roles. For user, they can record messages by solving some math puzzle. It takes about 1-2 minutes for one recording. So this math puzzle solution is the cornerstone of EnerID security. And then a user can create new blocks and earn coins. With coins, users can record urgent messages. For example, if when a farmer and the truck driver want to quickly generate a transaction receipt on the site, they don't want to wait, then they can record such urgent messages. And also farmer can transact coins, for example, with finance companies in bigger cities, then link them with more extensive economic activity. Servers just store chains, also run some protocol for providing the service for users to access the data on the chain. So we have the prototype deployed in CSIRO internet. So on that EnerID blockchain, we also consider the device security on the farm. Basically, security purpose can be so a device should communicate with the only correct device. So, for example, if the next neighbor farm also have such device, their data shouldn't be mixed together. And the data should be protected for not only confidentiality and also integrity, because this IoT device are deployed in open farm. So maybe they may have the physical attack. So our technology used for this problem is a symmetric key encryption. So there are already existing symmetric key encryption technique, like the advanced encryption standard encryption. But this existing encryption scheme is not very suitable for our scenario, because in our scenario, we use small IoT devices. They have limited memory, low network bandwidth, as shown in the previous talk. So the device might communicate with the satellite. So for each time, so the device and the satellite can only exchange a small number of bytes. So because the current encryption scheme generates very long ciphertexts, it can't be used. So we designed two schemes. One is briefly the first scheme. So it can generate very short ciphertext. For example, for 4 bytes message, it only generates 4 bytes ciphertext. And the second scheme provides not only confidentiality property, also the integrity. That's all my talk. Welcome your questions.
Thank you, Donji. I've got time probably for one quick question. I'm a producer. I want to do my recording into the EnerID system, and I don't know how to start. What can you tell me?
So I think basically for our current implementation, we have 2 interfaces. So one interface is just the based on web page. So basically farmers can record what they need to fill in for the paper format, they can input into the web page. Another one is just use the API. So maybe some supply chain company can develop more app with specific functionality for a farmer to use.
Thank you. It makes it sound so simple, but it's so complex.
Okay, sometimes. Yeah.
Thank you very much. That's great.